Painting in video games is a very common practice, more than one might think. It's often used to paint or interact with the environment, but also it is used to dirty the player and create consistency between him and the game world. Today we recreate this effect on Unity. This effect can be achieved in many ways. The most popular techniques are painting on the vertices of the meshes, painting using the light map coordinates, and painting on a texture in UV space. The choice depends on your scenario and on what you're aiming for. Every technique has pros and cons, and it is important to find what fits better your use case. As you probably already know, we have collaborated with André from Mix and Jam to recreate the Splatoon ink effect. To recreate the ink that dirtied the surface, we have chosen to paint in the UV space. The first thing we have done was to convert the workspace position in UV space. That way, the rasterizer will recreate the UV islands instead of converting the clip space into screen space coordinates. This, of course, means that our meshes need to be unwrapped and the UV has no overlapping triangles. Since the rasterizer expects coordinates in a range of -1 and 1, we need to remap our UV that has a range from 0 to 1. There isn't a common convention between coordinate systems to decide in which direction the axes point at. This can vary from graphics API and also from the software. To flip the UV correctly, we use the macro projection_param.x that Unity provides to us, which reflects the rendering projection metrics. With the correct UV in place, we proceed to paint on our texture. This texture will be used as a mask for the final material. Where the texture is still black, we will have the base color. In the other case, we will have the ink. In the fragment shader, we have used a signal distance function, keeping track of the distance between the world position of our virtual brush and the world position of each fragment. Also, we modulated this function using the radius, hardness and strength of the brush. In the initial phase, we used only the red channel to paint on the mask, using 2x1 as blend factors. But to support multiple colors, we have sampled the texture and interpolate between the background color and the color of the brush. Since we want to draw on a render texture that will be used as a mask, we use the command buffer API. The command buffer takes a list of rendering commands and will execute them when we want. We created a single command buffer held by our paint manager. When we need to paint, we can call the paint method that fills the command buffer and execute it. All the information needed by the buffer can be taken from the paintable class. Paintable represents an object where we can paint on. This class creates the texture and all the renderer. With this abstraction, we can call the paint method from any painter we want. We created a painter for the mouse, one for the collision, one for the particles, and so on. As the last step, we added another texture and created another shader to solve the island edges problem. Basically, during the rasterization, some pixels can be discarded because of the approximation. If the center of those pixels is outside of a triangle, they are not drawn. To solve this problem, we overestimated the islands considering the colors of the neighbors of every pixel. We created a shader that used our mask to draw on the ink on the base color. We also used some noise to deform the shape and calculate the normal. This is the final result. You can see it in action in the awesome new Mix and Jams video linked below. We want to take the opportunity to thank André for this collaboration. We have already worked together in past and every time it's more fun. In addition, we have used this effect in virtual reality to create something similar to the drawing effect from Half-Life Alyx. Let us know in a comment below what you think about this effect. Don't forget to subscribe, smash the like button and follow us on the other socials. See you next time. Cheers!